All right, welcome to lesson 9, metals versus nonmetals. And here we are going to be learning the properties of metals and nonmetals and how to classify them. Now we're going to introduce these properties in our lab. And here we're seeing some metals: gold, copper, iron, nickel, silver, and some nonmetals: diamonds, oxygen, carbon, silicon, boron. And so we're looking at metals, nonmetals, and metalloids. Now there's a third word. So we're going to define this, look at these properties that separate them in particular, and that's basically it. Let's go. So lesson 9, metals versus nonmetals, definition, metals. So here's a lot of metals all put together for us to see. Sometimes we actually messed with during our lab: aluminum, iron, copper, brass, zinc. Let's see, is that all? And then 10, yeah. Okay, so metals are elements. So they are a pure substance that is unique, and all all atoms of that substance all share properties. And these metals have certain properties, which is conductivity, malleability, reactivity, ductility. And the reason why they have these special properties is that their molecular structure, how the molecules in the metal are arranged, is unique. They have this regular fixed grid where the atoms are all kind of like layered on top of each other, but the electrons, you see them as red little dots in here, they just kind of like float around and move around. So nonmetals are elements that don't have any of those properties. They are not conductive. They are not malleable. We saw that when we busted a lot of them up by hitting them. They aren't nearly as reactive. They are not ductile. None of those things would bend for us, right? And the reason why these nonmetals don't have those properties is that their molecular structures are very different from how metals are structured. There's several kinds. There's a number of ways that these structures exist for our nonmetal friends. But one example is ice. Here on the right, this is a picture of how ice is structured when you get ice cubes, right, at the molecular level. And you can see that's very different from how the metals were layered on top of each other. The electrons actually form connections between the atoms to hold them together instead of floating around. Now, there's also metalloids. So a few here on the right, we have silicon, boron, antimony, and germanium. They have some properties that metals have, but not all of them. They're going to have, reference back to that sheet, they're going to have yeses and nos, not all yes, not all no. So they might be conductive, they might be malleable, they might be reactive, they might be ductile, but they will not be yes on all four or no on all four. And their structures will have certain similarities to metals, which is part of why they would have some of these properties. Now, the first property we're talking about is luster, which is how intensely the surface of the element reflects light back. You can see here the Lightning McQueen ka-chow, where he reflects light back on some of the fans. All metals will have some luster. Property number 2, conductivity, is how easily electricity and or heat, often things that are conductive to electricity are also conductive to heat for similar reasons, is transferred to and from the element. How likely you are to have as bad a time as this kid in the GIF. Now, electricity is conducted or carried on electrons, so the electron floating sea that metals have makes metals very conductive. Heat also gets transferred by free electrons more easily. Now, this property, ductility, is the ability to draw these metals into a thinner wire. And that's kind of a hard thing to picture. But the way to think about it, and have some GIFs here running, is that we actually push the metal through a cone-shaped hole that squeezes it and kind of bends it, in a sense, into a thinner, longer wire. Okay? And we tested this by bending, because anything that you can easily bend and have it stay, basically perfectly fine, like the metals did, are things that are probably ductile, because this is a kind of bending. All right, next one is reactivity. In this GIF, we see an acid solution that is having some probably magnesium put into it. I might show you guys this in class in the future if we get some time before Christmas. But reactivity is how strongly or likely that element reacts to other chemicals when exposed to them. Now, chemical reactions involve electrons, and all those free electrons make metals more likely to react. And because metals can easily react with oxygen to form rust or oxides via oxidation, metals often need some sort of protective coating when they're being used for normal activities. Now, this oxidation I just mentioned occurred when electrons are lost to oxygen and they form new chemical compounds, like rust, listed here as iron 2, oxygen 3. Now, there is a special metal, or metals, which are alloys. Elemental metals, like elemental or pure iron, do not have the exact qualities humans need for a lot of activities or a lot of processes. So we make alloys. They're special solutions, compounds of a primary metal with other metals and elements added, like your compositing material. This is very much like when we composited the Play-Doh. Stainless steel, which we have a picture of here, we use it for cooking a lot or for certain tools. It's mostly iron, but there is carbon, nickel, and chromium added, which make it resist rust and corrosion. That's why we use them for cooking. And that's it for our metals. Good luck on the activities, and I'll see you next time.